Hi everybody, we continue to review Greek calculus. On this part of the review we will have conic sections. First, the parabola. We'll find an equation for the parabola for this problem. So it's very important that we have to connect between the graph, the equation, and the characteristic of the conic section. Right. The vertex is 4 and 3, x equal to 4, y equal to 3, so this is the vertex. And then the focus is 7 and 3, x equal to 7, y equal to 3. That's the focus. And the directrix will be on the opposite side of the focus with respect to the vertex. So here we go from the vertex to the focus, x equal to, y, x equal to 4 to x equal to 7, so that will be 3 units. So that distance is 3 units long. We go the opposite direction to have the directrix. And the graph of the parabola will go around the focus through the through the vertex. So kind of like that. Just the idea. Alright. So this is the parabola that open to the right. So we have y minus something square equal to 4a x minus something. Right. The vertex is 4 and 3. So we have h and k, the vertex, 4 and 3. So h equal to 4, and that will go with the x, and y is going with k, go with y, so we should have that. And in this case a is 3, so we have y minus 3 square equal to 4 times a is 3, x minus 4, so we have y minus 3 square, 12, x minus 4. So that's what we have. Next we also have a parabola. The vertex is 8 and negative 3, x equal to 8, y equal to negative 3. So that is the vertex. The focus is at 8 and negative 5, x equal to 8, y equal to negative 5. So that is the focus. The distance between the vertex and the focus is a. Equal to 2. Opposite from the focus, we have the directrix. What's that? Now since the focus below the vertex, the graph will go around the focus and touching the vertex. So this one is the parabola that opens down. So we'll start with x minus something square equal to 4 times a times x minus something. Right. The vertex is 8 and negative 3. So h is 8 and k is negative 3. I don't know why I put 2x there, but this one open up or down, so it's going to be, should be y here. Right, so the h go with x, the k go with y, and the a is going to be 2. And furthermore, this one is this one opens down, so we have negative. Right. If it's actually very helpful if we actually start with the equation. If it open down, it will be x minus a squared equal to minus 4a y minus k, and then we just put in h for 8 into h, and negative 3 for k, and 2 into 8. Right. So we have x minus a squared equal to negative 8 y plus 3 next we have the equation, but we need to find vertex focus and the directrix. It will be very helpful if we still graph it. So y minus 4 squared equal to 12 x minus 3. We start with y squared, so it have to be left and right, and it is positive, so it is going to be to the right. Right. So compared to the equation y minus k, remember k always go with y, and h always go with x. So from here we have k equal to 4 and h equal to 3. Also for a is 12. So a is going to be 3. Right. Now, if we have these values, give us the vertex. The vertex will be at h and k, which is h equal to 3, k equal to 4. Right. So the vertex is 3 and 4. Let's put that on the graph. X equal to 3, y equal to 4. Again, we have y squared and then positive, so this one open to the right. And A3, meaning that we're going to go 3 units. 1, 2, 3 units to the right. So that is going to be a focus. So if we go 3 units to the right from here, the y will stay the same. We go from 3, 4, 5, 6. So 3, 4, 5, and 6. That will be the focus. Going to be 6. The y value is still the same as 4. Right. And then the directrix. The directrix is on the opposite direction of the focus. So we go 1, 2, 3 to the right. We go 1, 2, 3 to the left. And then we have that line, which is x equal to 0. That's the directrix. Next, we will find the vertex focus and directrix for this parabola. Right. First, we have to make sure it is in the right form, and which is not. So we should have x squared minus ax, which is good. So this one we start with x squared equal to ay minus 56. Right. First, we need to have a square on the right hand side. So we're going to need something, and we'll add that on both sides. And to determine what to be added on both sides to complete a square, we will take half of the middle term. So we take half of that, and then we square it. Half of -8 is -4, and then we square -4, that will be 16. Right, and then this will give us a square where we just put an x there, and on the right hand side we have ay minus 56 plus 16, that minus 40. So here we will rewrite this. We will have x minus 4 square, factor out to 8, we have y minus 5. Right, so that's what we have. Now we have x squared here. That obviously is going to be a parabola that open up or down. In particular, this one open up because we have positive here. Then compared with the standard form for the parabola that open up, x minus h squared equal to 4a y minus k. So compare these two equations. H is going to be 4, k is 5, and 8 is equal to 4a. So 4a is 8, so a is 2. Okay. From these two, the vertex is h and k, be 4 and 5. H equal to 4, y equal to 5. That is the vertex. And a is 2, and this one is positive here. So this one open up. If it open up, meaning that from the vertex we have to go 2 units up to have the focus. Focus will be 2 units up from it. If it is 2 units up, we're going to add 2 to the 5, the y component. So we have 2 units up from it. So be 4 and 7. Or we just count 5, 6, and 7. Right. On the opposite direction, we will have the directrix. So from the vertex, y equal to 5, 4, 3. So y equal to 4 is 3, 5, 4, and 3 is the directrix. Y equal to 3. Right, and the parabola. Again, if we want the graph to be accurate, we multiply 4 times a is 2, so it's going to be 8. It is 8, so we have 4 to the left and 4 to the right. So that is the lattice rectangle. And then we can have the graph. That go like that. Right. Right, next we'll go to ellipse. Now ellipse is different than parabola. For ellipse we have the center in the center. For the parabola we have the vertex in the middle. Right. Now which means from here we will have find h and k in this equation. That's not going to be a vertex, it's going to be a center. Right. So we just compare this. Use always x minus h and y minus k. So if we compare with that, we have h. is going to be 2, and k is -1. Remember, it's not going to give us the vertex like this, but it gives us the center. H equal to 2, k equal to -1. So h is the x component, k is the y component. Right, so the center is 2 and -1. Right. So x equal to 2, y equal to -1. Next, based on the graph, we have the 16 below the x and the 9 below the y. Taking the square root of that, so we have 4. Taking the square root of that, we have 3, which means the graph will go 4 units left and right for x and up and down for y. 4 units left and right, and 3 units up and down. Right. So 4 left and 4 to the right. 1, 2, 3, 4. 3 up. 1, 2, 3. 1, 2, 3 down. Right. Let's just draw a box here. Now, the vertex is the point furthest away from the center. So we have, this is the longest distance from the center. Of course, we're not talking about that. The ellipse is inside that box. So in this case, A is going to be 4, because that is left and right distance. Right. And then B is the other distance that is perpendicular to the major axis here. So that B is 3. Draw the ellipse first. So it won't be like this. Right. So A, remember, in the ellipse, the distance from the center to the vertex is the longest distance. So A is the longest distance. So A square stand by itself. We have B square plus C square. From here, we can solve for C. A square minus B square. A square minus B square. 16 minus 9, so 7. So C equals square root of 7. So which means from the center we go square root of 7, which is about 2. Just put in the calculator real quick. 2.65. So 1, 2. So there are 2 foci like that there. Right. So first, we have the center 2 and 1, and then we go 4 units to the left to get one focus. I'm sorry, one vertex. So we have the center here is 2 and 1. So we have 2 vertices. One from the center, 2 and 1. So 4 units to the left and 4 units to the right. 4 units to the right, we have 2 for x, 2, 3, 4, 5, and 6. So 6 and 1. And then 4 to the left, 2, 1, 0, -1, -2. So -2 and 1. So 6 and 1 here for vertex, and -2 and 1 for another vertex. The foci, there are 2 of them. From the center of 2 and -1. Notice that thing will go left and right. for two foci, we're just going to add or subtract into the x component. If we go up and down, it's going to be added to the y component. Anyway, so if we want to write that out, 2 plus square root of 7 negative 1, 2 minus square root of 7 negative 1. Right. So we start from the center for the ellipse, and then the longest distance from the center is to the vertex, and then the focus just Pythagorean theorem. Right. We have another ellipse here. Find equation of ellipse, describe, and then graph the equation. Right. We have two foci, negative 4 and 1. X equal to negative 4, y equal to 1. That one foci. And x equal to negative 4, negative 5 will be here. Another foci. Right. Now this one, what we are given are two foci, and then we know that the center must be right in the middle because it is symmetric on the center. So 1, 2, 3 up and 3 down. Right. Next, we have the length of the major axis is 10, so meaning that we have the major axis will be, of course, the major axis will contain all go to the center, go to two foci, and go to two vertex. So it will be like this. Is the major axis, and the length is 10, meaning that from the center to each side have to be 5. So 1, 2, 3, 4, 5 up. That gives us one vertex, and 1, 2, 3, 4, 5 down. That gives us another vertex. The distance from the vertex to the center, that is A, is 5. And the distance from the center to the focus, that distance is C, and C is 3. Right. So the major axis actually is the length is going to be 2A. So A is 5. Right. So now with that we have A is 5. And we calculated, we see on the graph C is 3. And then we just find the B, because A is the longest one. We stand by itself. A squared equal to B squared plus C squared. 5 squared equal to B squared plus 3 squared. So B is 4 squared, which is B is 4. Right. Yeah, 5 squared minus 3 squared, 16. I should write 16 instead. Right. Meaning that the 4 is going to be perpendicular. So 1, 2, 3, 4 on the other side. Left and right, 4 units. 1, 2, 3, 4. Right. Then if we want to graph it, we just draw a box. And the ellipse will fit inside this box. Now in terms of equation, equation ellipse is very easy. We have x minus something square over something square plus y minus something square over something square equal to 1. Right, first, the center, in this case, what we see is in the middle of the two foci. So the center here we have 1, 2, 3, 4 units to the left and 2 units down. Right? So h is equal to -4 and k is -2. So h is subtracted from x. So -4 here. And y, k is subtracted from y, -2. And then on this one we go 5 units up, 5 units down. So we're going to put 5 in below the y, because that's where the graph go up and down. And then 3 left and right. So we're going to put 3 under the x. When we clear out everything, simplify everything, we have x minus that x will be x plus 4 square equal to 9. Sorry, left and right 4 units. So 16. Y plus 2 square equal to 25 equal to 1. Right. Next, we also have an ellipse. Don't have equation. Right. The foci, as we know, 2 foci, so which is good. 1 and 5, x equal to 1, y equal to 5. Next, another focus, x equal to -7, y equal to 5. So we have 2 foci here and there. And another vertex is -8 and 5. Vertex will be there. Right. So first, the center must be in the middle of the 2 foci and the 2 vertices. So let's count. 1, 2, 3, 4, 5, 6, 7, 8. So cut in half. So be 4 to the left and 4 right to get the focus. 2 foci, that is. So we have the center here. And then the vertex have to be symmetry. Right, let's just find out the A, B, and C. So the distance from the center to the focus here, that distance is C, which is 4. And the distance from the vertex to the center, 1, 2, 3, 4, 5, so that is 5. So C is 4 and A is 5. We also have another focus, another vertex on that side. Right, so that's what we have. Let's try now what we have is the center. In the middle of the 2 foci will be 1, 2, 3 to the left, -3 and 5 up. So we do have the center, -3 and 5. Right. Next, if we want to draw it, we have A and C, we need B. So A square is the biggest by itself. So we solve for B square, 5 square minus C, A square minus C square, A square minus C square. So B is 3, meaning that we go 1, 2, 3 up, 1, 2, 3 down. Right. Then we draw the box. Right, it is inside here. So then 3 up 3 down. So the equation is x minus something square over something square plus y minus something square over something square equal to 1. Right. The center is -3 and 5. So that of course is h and k, and the h is -3 and k is 5. The h is subtracted from x and the k is subtracted from y. And on the graph we go left and right 5 units. So we're going to put 5 below the x and up and down 3 units that below the y. So we should have x plus 3 square over 25 plus y minus 5 square over 9 equal to 1. Right. Next, we just need to find the equation of the hyperbola. Right. A bit more complicated than the other two conic sections. So, the center is 7 and 6. So we know where we start with. X equal to 7, y equal to 6. By the way, that is h and k. 7 and 6. This is a center. The center. The focus is 1 and 6 and 6 and 6. So 1 and 6. X equal to 1, y equal to 6. That is one vertex. And then 1, 2, 3, 4, 5, 6. Okay, that is a focus at 1 and 6, and then another vertex. I mean the focus is 1 and 6, not the vertex. I just labeled that wrong. Focus is 1 and 6, and the vertex is 6 and 6. 6 and 6 will be right here. That is the vertex. Right, so focus here and vertex there. Right, now the distance from the center to the vertex is always a, so I have a equal to 1. And the distance from the center to the focus is always c. 1, 2, 3, 4, 5, 6. So c is equal to 6. For ellipse and hyperbola, center to vertex is a, center to focus is c. Right. Next, a square. Now in this case, c square. C is the biggest one, obviously bigger than a, so c squared by itself. And we can solve for b here. So b square is equal to c square minus a square. C square is 6 square minus a square, so that's 35. So b is square root of 35, and that is in the other direction, which is about close to 6. 1, 2, 3, 4, 5. So that is the distance b. Alright, so we have A, B, and C, which is good. And A and B, again, B is up square root of 35, down square root of 35. 1, 2, 3, 4, 5, a little more, so that. So we actually have the box square root of 35 up, square of 35 down. A is 1, so 1 left, 1 right. So if we want to, we can draw a box like this. And if we want to graph the parabola, we can draw the diagonal. Those are the two asymptotes, and the parabola will go to the vertex around the focus. So it will be that. Anyway, the equation. So this one open left and right. So we should start with an x. If it open up and down, we will start with y. And then subtract. And over something square here and something square there. Start with x. Now, the center is 7 and 6, so h and k, h is 7, y, k is 6. That's right. H is subtracted to x, and k is subtracted from y. Now on the graph, up and down square root of 35, so square root of 35 will be below the y, and we have 1 left, 1 right, so the 1 is below the x. And when we simplify this, we have x minus 7 square minus y minus 6 over 35. Of course, a square here. So that's what we have. So that is the equation. Next, we will have an equation, but now we need to find the center, the transverse axis, the vertices, the foci, and asymptotes. So a lot of information. But first, timestamp. Right. First, this one we start with an x. So again, it's going to be horizontal. And the center is h and k. So again, this we start with an x square. So compared to this form, x minus h square over something square minus y minus k square over something square. I'm not going to write a or b because that could be misleading. Actually, this is a, that is b, but again, that's not important. Right, so from here, h is going to be 4, h is going to be 1, and k is going to be negative 2. So just matching x with x, h is 1, and 1 y cancel, plus 2 equal to negative k, so k is negative 2. Right, that gives us the center. X equal to 1, y equal to negative 2. That's the center. Now it would be helpful if we draw the box, the graph here. the 4, take the square root of that, so it's going to be 2. So we're going to have, just going to put, this going to be 2 and 6. The 2 below the x, which means 2 left and 2 right. So 2 units to the left, 1, 2, and 2 units to the right, 1, 2. And then there's 6 square below the y. So 6 up, 1, 2, 3, 4, 5, 6. And then 6 down, 1, 2, 3, 4, 5, 6. And then I will draw the box from that. And then we can draw the diagonal. Which is the asymptotes, by the way. So just for that. So we have the center, the asymptotes. Now, remember this one x squared first, so that is it open to the right. So this is asymptote, so it will like this. So that is the hyperbola. Right, first, since it open to the right and we'll touch this box, this 2 point is going to be the vertex. 2 vertices here. And we originally we have 1 and -2. So if we want to go to the vertices 1 and -2, it is 2 units to the left and 2 units to the right. So we're going to plus or minus 2 to the x values because it's going left and right. So do that, we will have the vertices is 3 and -2, or -1 and -2. So those are the 2 vertices. The transverse axis is where the all of the vertex and the four sides and the center align. So this is the transverse axis. What else? So center, transverse axis, vertices. Now the four side. The four side is where the graph go around it. So it'll be somewhere in here. But let's just say, first we have the distance from the center to the vertex is 2. So we have A from center to the vertex. Center vertex is A, which is 2. And the other side we have 6 up and 6 down, and that is B. And C is going to be the biggest one, so C square is A square plus B square. 2 square plus 6 square, so C square is 40. So C is square root of 40. Right. Meaning that from the center we go left and right, square root of 40 units. Square 40 is about 14 point something. So it's going to be somewhere in here and there. Right. Again, to find the coordinate of the four side, we start with the center 1 and -2. Now, since we go left and right, square root of 40, to get the foci, we're going to add or subtract into it. That's what we have. So here we have the vertices here, and the foci, 1 minus square root of 40, negative 2, or 1 plus square root of 40, minus 2. That's 2 foci there. And finally, the equation of the asymptotes. So the asymptotes is going to be y minus k equal to the slope plus or minus the slope of just m x minus h. So k is negative 2, so y minus negative 2 equal to the slope, determine that in a minute, x minus k x minus 1, and then the slope. A slope is rise over run. And rise, it go up 6 units and then 2 units to the right. So 3. So we have plus or minus 3. Bottom line is the asymptotes is y plus 2 equal to plus or minus 3 x minus 1. So that's what we have. Asymptotes, foci, vertices, and then center. The graph look like this. Right. Graph the parabola. That should be easy if we just want the graph. Right. First, compared to this, start with y. So it's going to be up and down, the vertical parabola. So let's say y minus k square over something square, subtract x minus something minus h square over something square equal to 1. Right. From this equation we have k, compared to this we have k is negative 1 and then h is 2, right? K is negative 1 and h is 2. So from that, from this two we have the center is at 2 and negative 1. X equal to 2, y equal to negative 1. And then below the x we have the 3 square, below the y we have 3 square, below the x we have the 5 square. Right. So we start with the center 2 and negative 1, x equal to 2, y equal to negative 1. There. And then we will go up 3 and down 3. 1, 2, 3, 1, 2, 3. And then 5 units left and right. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Right. And then we can draw a box. So once again, we start from the center, 2 and negative 1, and then we go up 3 units because 3 square below the y square, and we'll go left and right 5 units because that's what we have below the x square. Right, so I have the box, and then the diagonal will give us the asymptotes. And then this one we start with the y, so this will be a vertical parabola, so it will be like this. So 1 and 2. Right, so we just want the graph, and that's all we do. If we want to, we can find everything else. Let's just also do that, even though the question did not ask us for that. So again, the center is 2 and -1. That's where we start. The vertex, there are 2 vertices, one here and one there. That's where the graph touch the box. So to go 3 up and 3 down, and the distance between the center and the vertex is a. So that is a, and this is a, which is equal to 3. From the box, the other distance is going to be b. So 1, 2, 3, 4, 5. So b is 5 and a is 3. C, the distance from the center to the focus, is going to be the longest. Uh, 5 square, 25 plus 9, 34. So C is square root of 34. And it must align on the axis. Remember, the vertices, foci, and the center must align on an axis called the transverse axis. So we'll go square root of 34 up and square root of 34 down. If we're going to write that, the foci based on the center, and we go up 3 and down 3. So we're going to add to the y component. So we have 2, 4, and 2, and it's -1. So 2 and 2, and 2 and -4. Right, 2 foci there. And then, sorry, that is the vertices, not foci. Yeah. The foci though, again, start from 2 and -1. We found out that C is 1234, which is the distance from the center to the foci, to a focus. So that is the coordinate of the 2 foci. Again, if we go up and down, we just add to the y component. We go left and right, we will add to the x component to have the vertices and have the foci. And asymptotes, rise over run, give us the slope, and so all of that. Do the next 2 together. So we have the equation in quadratics. Right. So we just have the A, the B, and the C. A and C actually doesn't really matter. But this case, A is 1, B is 10, and C is 25. I'm using the capital letters not to confuse with the ABC in the next section. Right. What we do is we're going to find the discriminant. So which is D, which is or delta b squared minus 4ac. So it is exactly like the one in the quadratic formula. B squared minus 4ac is called the discriminant. So let's just do that first. B squared minus 4ac, tan squared minus 4ac, 100 minus 100 is 0. So after we found the discriminant, there will be 3 scenarios. When the delta being positive, it's going to be hyperbola. Hyper means over, so it's going to be bigger than 0. Delta equal to 0, that is for parabola. And when delta less than 0, it is going to be ellipse. So this is equal to 0, so it's going to be the parabola. Right, very straightforward. Next one we have A is 4, B is 5, and C is 3. Okay, A, B, and C. Then we find delta equal to B squared minus 4ac, 5 squared minus 4ac, 25, 16, and minus 48. So this is negative. And if it's negative, it's going to be an ellipse. Right. So that's all we do there. Right. The next two actually kind of complicated, and there's not much option we can do. We have to be extra careful. Right. So we turn this polar equation into a rectangular equation, meaning that we're going to write this equation in terms of x and y. Like I said, a bit tricky though. So let's just write down what we can use. Right. X is equal to r cosine theta. So there's nothing new there. Y is r sine theta. X squared plus y squared is r squared. And tangent of theta is y over x. So we can only use these 4 things. Right. So we have cosine here. Obviously, it's not going to help if we just have cosine. If we have r cosine, then that's good. Right. Now, first thing, why don't we cross multiply, and we have r equal to 2 minus 2 cosine theta equal to 2. That gives us 2r minus 2r cosine theta equal to 2. Right. Yeah, let's divide everything by 2, right? Because we can divide everything by 2, so we have r minus r cosine theta equal to 1. Yeah, let's divide everything by 2 here. Next, r cosine is going to be x. So we have r minus x equal to 1. Just good. Now we still need to turn the r into x and y. So there we can just square both sides. But if we square both sides, there's a term that is rx. So before we square both sides, it will be much better if we add the x on both sides. So in that case, when we square both sides, we just have the r square by itself, which is a lot better than the r with the minus x. And then we just multiply it out. R square, x square plus y square, and x plus 1 square multiplied out, x square plus 2x plus 1. Don't forget there's the middle terms. And then x square cancel. We have y square equal to 2x plus 1. Right, so that's the first one. There's not much option we can do. We cannot square both sides on this step, because if we do that on x mixing, and yeah, you don't want to deal with that. Right. I will rewrite this as 4 over sine, 4 over cosine, which is secant, and 1 over cosine plus 2. Right, secant is 1 over cosine, 1 over cosine there. Right, what I do here is I'm going to multiply cosine on the top and cosine at the bottom. So in that case, we will have r equal to cosine cancel, that's going to be 4. And then cosine multiplied in here, just 1. And that 2 cosine. Right, so that's kind of like that form, right? So now we cross multiply. We have r 1 plus 2 cosine equal to 4. Multiply out r plus 2r cosine theta equal to 4. And r cosine here is x. So I have r plus 2x equal to 4. Again, we have to subtract the 2x on both sides. And then square both sides. R squared turned into x squared plus y squared, but the right hand side, let's just say 4 minus 2x, 4 minus 2x. Multiply now 16, 4 minus 2x, that minus 8, minus another minus 8, so minus 16x. Plus 4x squared, and then x squared plus y squared. So if we want to, we move everything on one side, but I think that's good enough. We can just stop it like that. Right, the next two is we turn this parametric form into a rectangular form, meaning turn to x and y. Timestamp. So for these two, actually two different things. One of which is easy to eliminate t, and this one is not so easy to eliminate t. Right. So first, we have t is between -2 and 3. X is that, y is that. So it's very easy. Either we solve for t in terms of x or y, then substitute into the other equation. So from here, x equal to 3t give us t is equal to x over 3. And we just substitute this into this equation. So we have y equal to x over 3 plus 3. It's good. The only thing that need to do is the range of t. So we have -2 less than or equal to t less than or equal to 3, we need to divide by 3 everywhere to have x over. Never mind. Sorry. Again, -2 less than or equal to t, less than or equal to 3. Now, we need to turn the equation in terms of x equal to 3t, so we should multiply 3 here, 3 and 3. So we have -6 less than or equal to 3t, less than or equal to 9, and the 3t of course turn back into x. So if we're going to write like this, the x will be between -6 and 9. So that's what we have. So two ways to eliminate t. The first one is solve for t in terms of x or terms of y, substitute into the other equation. The second one, when we have the trig function like this, it's not quite easy. So I will write like this: x equal to 4 sine t. So we can write sine t is equal to x over 4. Y equal to 4 cosine t. Cosine t is equal to y over 4. Right. Now let's square both sides. Give us sine square and x square over 4, so it will be x square over, yeah, I just write like that. Cosine square and we'll just add side by side. Sine square plus cosine square is 1, and the other side is going to be x square over 16 plus y square over 16. So we have the equation, which is good. By the way, that obviously is an ellipse, right? If we're going to draw center 0, 0, 4 up, 4 down, 4 left, 4 right. So this is a special ellipse, a circle, radius 4. So if we want to write the domain or the range, the x values between the 4 and -4. Right, so especially when we have the sine, cosine, so we just isolate the sine, cosine, square them. Sine square plus cosine square is going to be 1, so it's we have the equation. Right. Next we write the parametric form for that equation. Right. So it's very easy. The simplest possible way is just that x equal to t, then y equal to 2x minus 5, and we substitute in here y equal to 2t minus 5. On this problem we are not given any domain, any range, so we just say x equal to t, y equal to 2t minus 5. So t pretty much can be anything. Right. There's no restriction there. Right. Next one. Find the parametric equation for an object that moves along this ellipse. So again, on this case, not going to be easy. We just lay x and t equal each other. In fact, those still kind of related. Problem. So remember, when we have 1, the very common identity is cosine square plus sine square is also equal to 1. So then we can match. We can either matching this with the cosine square and match that with the sine square, or the x square over 64 with the sine and the y square over 81 with this the cosine. Either way, but I will just do this. So we write let x square over 64 equal to cosine of square of t. We can take the square root on both sides, right? That gives us x over 8 equal to cosine of t. So x equal to 8 cosine t. Right, similarly, y square over 81 equal to sine square. So we take the square root. Y over 9 equal to sine of t. So y equal to 9 sine t. So we have a parametric equation x and y in terms of t. The only thing need to determine is the domain for the parameters. In this case, we will just let it equal to 0 to 2 pi, which will go one complete revolution around an ellipse. Right, and for timestamp. Next we have partial fraction. This will have to be a bit tedious, and if we can use color code or any system that help us with the bookkeeping, that would be great. Right, first we have the two factor in the denominator, so we're going to have two fractions. And the top, the degree on top is always less than degree the bottom. Since the bottom is x, power of x, which is 1, the top has no power, meaning a constant. Right, multiply both sides by the least common denominator of x minus 2, x minus 4. So multiply that, would cancel with this. The left hand side is x minus 12 equal to a. Now, let's just write out for a moment. Multiplied x minus 2 plus b over x minus 4 multiplied by x minus 2, x minus 4. That cancel out, that cancel out. We have x minus 12 equal to a x minus, forgot the x minus 4 here, sorry. So x minus 2 cancel out, we still have x minus 4. And then b, x minus 4 cancel out, we have x minus 2. Right, multiply it out. Ax minus 4a plus bx minus 2b equal to x minus 12. Right, combine like terms. Now this is the, we have, those are the x's. Like I said, if there's a way to combine this systematically, bookkeeping, that would be great. And then minus 4a minus 2b and then we'll just match them. The coefficient of x must match with the coefficient of x. So we have 1 equal to this. A plus b is equal to 1. And then next we have negative 12, have to match with this constant, minus 4a minus 2b is equal to minus 12. Right, this one we're going to use the calculator. Wrong one. Okay, let's put that there. It's fine. Right. Now, I'm going to put this in the matrix form. Coefficient of A is 1, coefficient of B is 1, and then the numbers 1. Let's draw a line to distinguish them. Coefficient of A is negative 4, coefficient of B is negative 2, and then negative 12. So we have the matrix like that, and then we're going to operate the reduced row echelon form on that matrix. Right. So first, the RREF, we're going to hit second, and the matrix, go to math, option RREF is way here. Again, it is RREF, not REF. Right. And then we're going to put the matrix 2 rows and 3 columns, alpha and zoom, to get to the matrix mode. 2 rows, 3 columns, and we have that. X equal to 1. It's important that we don't hit enter here, just hit 1 and the next button. 1 and then 1. Negative 4. Again, the enters here, we don't hit that at all. And don't use the subtraction sign, use the negative sign. So negative 4, negative 2, and negative 12. Do that when we have this. Just let's write that real quick. 1, 0, 0, 1, 5, and negative 4. So that is A and that is B. So the original problem, x minus 12 over x minus 2, x minus 4 will be equal to 5 is A, so we have 5 over x minus 2, and then negative 4, x minus 4. Right. Right, next we have 3 factors. And all of them are different. So we're going to have like that. And then again, the power on top is always 1 less than the bottom. So just A, B, C. If we have x squared at the bottom, the top will be a squared. I mean, going to be a linear function, ax plus b. Anyway, multiply by the least common denominator. I just copied from there for no reason. Sorry. It's going to be x plus 1, x minus 1. Right. Right, multiply x plus 1, x minus 1, plus b over x plus 1, x plus 1, x minus 1, and then c x minus 1, common denominator x plus 1, x minus 1. Right. Of course, we multiply that on this side as well. X plus 1, x minus 1. And that cancels the whole denominator. So on the left side, we have 2x squared minus x minus 9. On the right hand side, the x cancel out. We have x plus 1, x minus 1. X plus 1 cancel. X minus 1 cancel. Right. Now we just multiply everything out. X times x squared, x times minus 1, so minus x plus x minus 1. So we just have that. B, x squared minus x, and then C, x squared plus x. Multiply everything out. Ax squared minus a plus bx squared minus bx plus cx squared cx. Right. Combine like terms. Ax squared x squared, we have those three things, so a plus b plus c x squared. Next, x minus b plus c x, and that's the only thing left. It's just the negative a. Now we just match the coefficient. On the left hand side we have 2x squared, so a plus b plus c must be equal to 2. By the way, this method is called the undetermined coefficients. Negative b plus c is negative 1, and negative a is equal to negative 9. Right, so that is the system of equation. If we write the matrix 1, 1, 1, and 2, 0, negative 1, 1, and negative 1, negative 1, 0, 0, and negative 9. Right, and the calculator again. Second matrix, go to math, RREF, alpha, zoom. This will have 3 rows and 4 columns. Right. 1. Don't hit the enter. Hit next. 1, 1, 2, 0, negative 1, 1, negative 1, negative 1, and then all the way to negative 9. Right. So when we do that, after we do the RREF, we have A is equal to 9, B is equal to negative 3, and C equal to negative 4. Bottom line is the original problem. We can factor in term of A, which is 9 over x, plus B is negative 3 over x plus 1. And then negative 4 for C, which is x minus 1. So the original rational function is decomposed into these three. Next we have the repeated factor. So I have x plus 1. Right. So we're going to have 1 for x plus 2. And for x plus 1, it is repeated with the square. So we're going to have the x plus 1 square, x plus 1 first, and then the x plus 1 square. If it is repeated, we have to do that. By the way, let's say if this is to the third power, we're going to have x plus 1 square, x plus 1 cube. So multiply everything by the least common denominator, that. So negative 4x squared minus 14x minus 15 over x plus 2 square, x plus 1 square. Of course, the square is on the x plus 1. Right, the least common denominator is x plus 2, x plus 1 square. I have to write a little small because it's very long problem. X plus 2, x plus 1 square, b over x plus 1. So I have x plus 2, x plus 1 square, and then c over x plus 1 square over x plus 2, x plus 1 square. Right, this common denominator multiplied to everything. Right, cancel out this. So we just have negative 4x squared, negative 14x, negative 15. Right, cancel out 8 x plus 1 square, b x plus 1 cancel out, we have b x plus 2 only one of them cancel out, so we have x plus 2 and then x plus 1, and then c x plus 1 cancel out, just x plus 2. Right, it's not that difficult. It's a bit tedious when we have to multiply all of this out. So x plus 1 times x plus 1 plus b x squared x 2x, so that's 3x plus 2, and then cx plus 2c. Right, x squared plus x plus 1 and then bx squared 3bx and then 2b and then cx plus 2c. So ax squared plus 2ax plus a plus bx squared plus 3bx plus 2b plus cx plus 2c. Let's have to be careful when we do this kind of problem. It's a bit tedious. Right, systematically, there should be a way to combine this so that a and b, that is the x squared. See the ax, we have 2a, 3b, and the c. 2a, 3b, and the c. And left, what's left is just a, 2b, and 2c. Right. On the left hand side, we still have negative 4x squared, negative 14x, negative 15. Right. For x squared, we have negative 4. So a plus b equal to negative 4. Next equation, 2a, 3b, and the c equal to negative 14. And a plus 2b plus 2c equal to negative 15. So we can write system of equation and then do the reduced row echelon form or the RREF. That technique it actually is it is in the linear algebra class. RREF. Right. Second matrix, go to math. RREF. Right. Alpha zoom. Right. 1, 1, 0, negative 4, 2, 3, 1, and negative 14, 1, 2, 2, negative 15. Right. It's going to be A is negative 3, B is negative 1, C is negative 5. When we put all together, A is negative 3, so will be over x plus 2. B is negative 1 over x plus 1, and C is negative 5 over x plus 1 squared. So that's what we have. So that is where we have the repeated factors. So we should have two of them. Right, next we have a linear and a quadratic. X minus 1, x squared plus x plus 1. Right. First we have only two factors, so we have x minus 1 here. Will be 8 on the top, and then we have x squared plus x plus 1. Just need to factor it completely. If that is the case, x squared at the bottom, the top degree will have 1 less. So we should have degree 1 over degree 2, which is good. Right, and then multiply by the least common denominator. Right, multiply by that. Right. So of course everything cancel on the left hand side. 10x plus 2 equal to x minus 1 cancel out. Have 8 x squared plus x plus 1. And x squared plus x plus 1 cancel out. And I'm x minus 1. Right, multiply this out. Ax squared plus ax plus a, and this b x squared minus bx plus cx minus c. Right, combine like terms, square and then the x a minus b plus c x, and then just a and c left. So combine like terms. There's no square here, so we're going to let a plus b equal to 0. For x, we have a 10 here. So just matching the coefficient. And a minus c. Right, matrix 1, 1, 0, 0, 1, negative 1, 1, 10, 1, 0, negative 1, and 2. Reduce row echelon form. Second matrix. Go to math. Option that. Right. Alpha zoom. This is a 3 by 4, which is good. Right. 1, 1, 0, 0. So we just skip those two. 1, oops, negative 1, 1, and 10. 1, negative 1, and 2. So you have 4, negative 4, and 2. A is 4, B is negative 4, and C is 2. So we put it back into the original. In this, we have 4 over x minus 1 plus minus 4x plus 2 over x squared plus x plus 1. Right. So that original rational function is decomposed into this. Right. On this one, we're not going to decompose completely, we just write the form of it. So that's the idea here. So if we have 3x cubed, let's do x squared plus 5 square x minus 2 cubed. Right. First, we're going to have two factors of this because that is the square, so we have one of them with the first power, and then the other one with the second power. Right. That for the first part. This next we have x minus 2 cubed, so we're going to have 3 of them. Starting from the first power, second, and then third. If we have to the fourth power, there will be one more to the fourth power, but the power decreasing 1, 2, 3 for 3, 1, 2 for 2. Right. Now determine what will be on the top. Remember, the top, the power have to be less than the bottom. Furthermore, we're not talking about the power either. So if the bottom is x squared, on the top it can be a linear function. Bottom is x squared, like I said before. The power here, we're not going to consider that. So it will be cx plus d. And then for this one, e, just a constant. And then that another constant. And that a constant. Note that it doesn't matter the power of the factors. It's just what inside. And whatever degree of that on top cannot be more than it. Right. So that is that. Next we'll have the series and sequence. Right. For the first 4 terms, so that's very easy. So just say first term, second term, third term, and fourth. So pretty much what we do is we're just going to put 1, 2, 3, and 4 into n, and we'll do that. Right. Just want to show you to do that. We can use a calculator as well. Alright. So if we want sequence, the calculator, we can switch into the sequence mode. Hit mode. Sequence is option here. And then quick. Right. And then we just hit y equal to. Right. We'll see the sequence. We're going to type exactly like we see here, 3 to the n power. If we want fraction, alpha y equal to, we have 3 to the n power. You see that button? Okay, we can zoom in further up. On that button, the first one, x for function, t for parametric, theta for polar, and n for the sequence, corresponding to function, parametric, polar, sequence, which, I mean, depends on what mode we set it, the calculator at. It will give you a particular variable there. Right, so it's going to be n because we set in the sequence. So we hit that to give us the n. Next, n plus 3 factorial is math, probability, option number 4. And then just hit second graph. First term is that, second, third, and fourth. Right. Let's say second trace. Can we do that? Values. Right. N equal to 1. 1 over 8. N equal to 2. 3 over 40. N equal to 3. 3 over 80. N equal to 4. 9 over 650. So pretty much we just put the numbers in that, and that's it, first 4 terms. Right, the next one kind of the same thing but in recursion. I'm going to do by hand first, and then we can use the calculator. So first term is 1 when n equal to 1. When n equal to 2, we have a2 is equal to, of course we don't know from here, but we can put 2 here and here. 4 times a 2 minus 1 plus 3. 2 minus 1 is just a1 plus 3, and suddenly we can substitute into this. So be 4 times 4 plus 3. Uh, 12, so that's 15. 16 and 3, 19. Right. Next, n equal to 3. We have a3. 4 times a3 minus 1 plus 3. 4 times a2 plus 3. We can substitute the 19 into a2 here. 4 times 19 plus 3. 4 times 19 is 76 plus 3 is 79. And then n equal to 4. Do the same thing, just do that. So this is called a recursive sequence. So we need this term, put it back, provide the next term, and then just generate the next. Right, calculator. Y equal to, right, we start with the first term, which is that. Now, instead, we're going to write like this. So instead we write a sub n is going to be u of n. Right, 4 times, we need a little u. So second, that of n minus 1. So rather than write a subscript n minus 1, we write u in the parentheses n minus 1. So this is a sub n, a of n minus 1 plus 3, and the first one, the sequence is 4. Right, and then we can go to the table and we see all the values. So 4, 19, 79, and the next one is 319. Right, so that is the recursive sequence. Right, summation. Right, I'll do this two together. Right, 2, 4, 6, and we assume that on the even number. So on the even number, we can write as 2 times 1 plus 2 times 2 plus 2 times 3 and 2 times 9. So the numbers that change, increasing f1 every time. We go from 1, 2, 3 on the way to 9. So we say k go from 1 to 9. And then the 2 are constant. And then the k will take values from 1 to 9. So that's what we have. Right. So we need something that is consistently stay the same, which is 2 in this case. Anything changed with the equal increment, we call that going to be k, and we're going to do that. Next, I will rewrite the 1/2 as 2 over 4. Right. Notice that we have 1, 2, 3, 4, 5. Look like on the top it will go from 1 to 13. So if we put in the summation, it will be from 1 to 13. And then that will be k. So that values will take from 1, 2, 3 on the way to 13. The bottom will be 3 to 15. Actually, you see that the bottom is 2 more than the top. So we're just going to say k and k plus 2. Right. So that's what we have. Right. So there's something after. Right. Let's quick this. Right. Hit math. Just go down to the summation, and we can choose any variable. In this case, n. It's perfectly fine. Equal to 1 to 5, and then here we have n plus 11. Right. Just do all the summation first, and we have 70. Right. The next one is the same thing. Just going to put 3, 4, and then 5, and that's it. Or we just use the calculator. Again, math, option 0, I think, summation. Whatever the variable is, go from 3 to 5, and then we have n squared plus 1. There. Right. Next we will have the arithmetic sequence, and then later geometric sequence. Right. Right. Find the n term of the indicated arithmetic sequence whose initial term 7. The common difference is d. So arithmetic sequence a sub n equal to a1 plus n minus 1 times d. So we start with start with 7, and then we just subtract 7 every time. So pretty much we subtract 7 every time. And the negative 7 is the common difference. Right. So again, to get to the fourth term, we're going to have 1, 2, 3 steps. So to get to the n term, we have n minus 1 step. So always 1 step less to go from the first to the n term. So we start with 7. And d is negative 7. So for each step, we subtract negative 7, and then we just do that. To get to the n step, we need n minus 1. I mean, to get to n, we need to take n minus 1 steps. So now if we have 13, so just put 13 in for n. So 7 minus 12 times 7. So negative 77. Right. By the way, the n term, we can use this one. The 23rd term of the arithmetic sequence. So we start with the first term is 0. The difference to go from this to the next is going to be 6, because we need to add 6 every time. So that's what we have. And arithmetic sequence an equal to a1 plus n minus 1 times d. We start from 0, and it's going to take n minus 1 step times 6. And 23rd term, so 23 minus 1 times 6. So 22 times 6, 132. Right. Next, we have the 10 term is equal to negative 12, and the 16 term is equal to negative 24. And good thing, it is still arithmetic sequence, so an equal to n a1 plus n minus 1 times d. To put everything we know in this equation, we have a10 equal to a1, which we don't know, which is fine. N we do know is 10, so 10 minus 1 times the difference, we don't know that either. Right. And this is supposed to be equal to negative 12. Next, 16, start from the first term, n is 16, d we don't know, but that is equal to negative 24. So to rewrite this, we have a1 plus 9d equal to negative 12, a1 plus 15d equal to negative 24. Right. By the way, if we want to use the matrix like we did before, it's perfectly fine. So again, the matrix 1, 9, negative 12, 1, 15, negative 24. 2 by 2 we can just do by hand, but let's use a calculator here. Right. Second matrix, reduce row echelon form. Two and 3. Right. X equal to 1, 9, and negative 12. 1, 15, and negative 24. Right, 6 and negative 2. So when we do that, a1 is equal to 6. a1 is the first one, d is the second one, negative 2. So the formula is an equal to, I will give the recursive. a1 plus n minus 1 times d if we want the formula, which is perfectly fine here. 6 plus n minus 1 times negative 2. Right. However, this one want a recursive formula. So this is arithmetic. So good thing we know that we can say the first term is equal to 6. And the next term is equal to the previous term. Subtract 2. That is the recursion formula for that sequence. Right, this is the sum of the arithmetic sequence. Right, so here we will have the first term is -6, and to get from this term to the next, looks like we're going to add 5 to it. So that is the common difference. Sorry, first term is -6, and then we'll plus 5 to it. Common difference is 5. This we don't know what term is it, but we know it is follow the formula for the n term of the arithmetic sequence. So a1 is -6, and then n minus 1 times d, whatever it is, it have to be equal to 39. So we can solve it easily. -6 plus 5n minus 5 is 39. Add 11 on both sides. 5n equal to 50, n is equal to 10, so we have 10 terms. And finally, the formula for the sum of the first n term is equal to n over 2 a1 plus an. In this case, I'm going to use this formula because we know the first term is -6, the n term is 39. So we have 5 times 39 minus 6 is 29. 29 times 5 is 150, so 1. 5 and then 4, so sorry, it's not 29, it's 34. Sorry, 9 is 33, okay. 5 times 33 is 165. Right, it should be 33, sorry. Just simple arithmetic for arithmetic sequence. Right, next, this is the sum of arithmetic sequence. So a brick staircase, total 14 steps. The bottom one has 101, and each one above is 4 less than it. So we start with 101, and then the next one is 4 less than it. So we subtract 4. And then just keep subtract 4. Sorry. And then so on, and we have 14 of them, so n equal to 14. Right, so the sum is going to be that. We know n is equal to 14. We know a1 is 101. Suddenly we can find an. So an equal to a1 plus n minus 1 times d. We want on the top step. Uh, 14 minus 1 times d minus 4. So 101, I just use a calculator here. 101 minus 4 times 13, 49 steps. So the top have 49 steps. N is 14 over 2. 101 plus 49. So 7 times 50. I mean 7 times 150 is 1050 bricks. So this is the sum of arithmetic sequence. N divided by 2 times the first plus the n term. We know 14 terms. So the n term is when n equal to 14, which is 49. And substitute in there. That's what we have. Next, we will go to the geometric sequence. The n term is equal to the first one times r to the n minus 1. So the first term, I mean a9, so we're just going to put 9 in for n. The first term is 5, common ratio is 3, 9 minus 1. So 5 times 3 to the 8 power. I'm not going to do that by hand. 5 times 3 to the 8 power. 32,805. The next one. The first term, this is also geometric sequence. The first term is negative 2. To get from this to the next, we need to multiply by 3. So the common ratio is 3. So we put in the formula. So an equal to a1 times r, that formula, to n minus 1. So yeah, pretty much that. Yeah. So for geometric sequence, we need to know the first term, where we start, and the common ratio, how to go from this term to the next. Next one is the sum of the first n terms. Geometric sequence. So Sn equal to a1 times r to the n power minus 1 over r minus 1. Either we use that formula, or we can use the 1 minus r to the n over 1 minus r. So either we start with r minus 1 or 1 minus r. So I have to be consistent with this. Usually I'll choose the first one. Right, so we have 11 terms. So n equal to 11. The first term we know is 2. The common ratio, to get from this one to the next, we need to multiply by 2. And n is equal to 11 because we want the sum of the first 11 terms. So divide by 1, so that is 1, so we have 2 times 2 to 11 minus 1. 2 to 11 is 2048 minus 1. So that is 2 times 2047 is 4092 94. Right. So that's what we have. Now this is the sum of infinite geometric series. 157, 158 are together. Times them. Right. infinite geometric series, so the sum of infinite geometric sequence is that. So it's easy. The first term divided by 1 minus r, but only if the r is between 1 and -1. If we don't have that, the sum does not exist. Right, so let's write out the first term here is -30. To get from this to the next, look like we have to multiply by 1/5. So yeah, that's right. And the 1/5 is between -1 and 1. Yeah, so that check. So the sum is equal to the first term 1 minus r. So the first term is -30, 1 minus r. So -30, 1 minus 1/5 is 4/5. Divide by fraction is multiply reciprocal. 30, so that's -150 over 4, which is -72, -75 over 2. Right, the next one we have, the first term is 1/4. To get to the next term, we need to multiply by a number. If we don't know that, we just divide backward. -1/2 divided by 1/4, 1 divided by -1/2, and so on. Look like if I do that, 1 divided by -1/2 is -2. So the ratio is -2, and it's not between -1 and 1. So the sum did not exist. Because r is not between -1 and 1, so we just say because r is bigger than 1. Yes. It has to be between -1 and 1 to use that formula. Otherwise, the sum does not exist. Next, let's spread this as repeating decimal as a fraction. So we write that as 0.45, 45, 45, and so on, which is 0.45 plus 0.0045 plus 0.000045, and so on. So that's the idea. 45, and then move decimal point 2 places to the right, and then just keep doing that. And so this is the infinite geometric series. The first term is 0.45, and the common ratio is divided backward. 0.0045, 0.45, it is 0.01. As 0.01 is between 1 and -1. So in that case, the sum is equal to a1 over 1 minus r. a1 1 minus r. So we have 0.45 over 0.99. So move the decimal places. We have 45 over 99. Divide by 9, we have 5 over 11. Right. So that's what we have. Right. So a ping pong is dropped from the height of 9 feet, and then it's always rebound 1/3 of the original distance. So try to draw this out. Originally it is 9 feet, and it drops straight down. So now we the total height. So first one is 9. It's the total height, not the total distance the ball travel. So we will always bound up to 1/3 of the original one. So we'll go up and down. It's 1/3 of it, so 1/3 of 9, so it's going to be 3. And then it will up and then down. It's going to be 1. So the total rebound height is 9, 3, and 1, and then indefinitely going down like that. So we're going to have the first term is going to be 9, and then the ratio is 1/3. This one is easy to see. It's always 1/3 of the previous term, and the 1/3 is between -1 and 1. Yes, that's good. So we say we can use the sum of the infinite geometric series, the first term divided by 1 minus r. Always check this condition first. So 1/3, 9 over 1 minus 1 over 3. 1 minus 1/3 is 2/3. Multiply reciprocal. It is going to be 27 to 13 and a half. Right, so that is the total height. Right. Now I read the problem again. They only asked for the rebounding height, so that is very important. So we have to subtract the original height because the initial height is not the rebounding. So what is rebounding height only? So we're talking about the rebounding that going up only. So actually just only 4.5. Right. Again, we're not counting the initial height. We're just asking for the rebounding height. So in this series, actually we don't have the 9. We start from 3, 1, 1/3, and so on. So since we already did that, we have to subtract the initial height. But regardless, that's what we have. Right. So with that, we finish all the questions for the pre-calculus. I hope you find this series helpful. Thank you for watching.